Removing common factor, student learning objectives. Define a factor. 2, factor the largest common factor from a polynomial. Define a factor. The numbers that we multiply to get another number are called factors. For example, 3 times 5 is equal to 15. 3 and 5 are the factors of 15. Also, the algebraic expressions that we multiply to get another algebraic expression are called factors. For example, x, y. X and y are factors of xy. Factor the largest common factor from a polynomial. To factor a polynomial where each term of the polynomial has a common factor. 1, identify the largest common factor for the coefficients and the variable with the largest exponent common to all terms. 2, the product of the largest common factor for the coefficients and the variable with the largest exponent common to all terms is the greatest common factor of the polynomial. To find the second factor, which is a polynomial, divide each term of the polynomial by the greatest common factor of the polynomial. Divide each term of the original polynomial. By the of the polynomial. We don't know the second polynomial yet. We're working to get the second polynomial. Okay, example, factor the greatest common factor. So the greatest common factor is the number that is a factor that is common, the largest factor that is common to each of the coefficient terms. That's for the coefficient terms. So 20, we can write it as 2 squared times 5. 45 can be written as 3 squared times 5. 25 can be written as 5 squared. So if you notice that the bases are prime numbers. So we want to write each coefficient term as a product of as its prime numbers. We want the factors to be prime numbers here. So we break the coefficients into product of their prime numbers. If the prime number occurs as a factor more than once, then that the number of times it occurs as a factor becomes the exponent. For example, for the 2 squared, 2 occurs as a factor twice. 2 times 2, which is 4. So we write it as 2 squared. 4 times 5 is 20. 3 squared is 9. 9 times 5 is 45. 5 squared is 25. The greatest common factor, we call it abbreviated greatest common factor, is the prime number that is common to all numbers, which is 5. But then we have exponents here are 1. We don't write it when it's 1. And then we have 2 exponent 2. Which one do we choose? The 2, the 1, or all of them? We choose the 1 with the smallest exponent. The smallest exponent is 1, so the greatest common factor for the numbers is 5. Now we pull 5 out. We need to also find the greatest common factor for the variables. The variables, the base is just x. And the greatest common factor is going to be the, let's look at a wording here. We said the variable, okay, the largest common factor for the coefficients, okay, which we found the largest common factor for the coefficients. And the variable with the largest exponent common to all terms. So the variable here is x, and the largest term that is common to all 3 terms is 4. So if we pick 8, for example, x to the power of 8, x to the power of 8 does not exist in the third one. The largest exponent here is 4. So we don't have additional x to the power 4 here. So it's not the additional x to the 8. 4 is not a common factor. So x to the 8 is not common to each. So basically, we're going to pick the exponent, the variable with the smallest exponent that is common to each. So in this case, it's x to the 4th power. So the product of the greatest common factor for the coefficient times the greatest common factor for the variable terms is going to be the greatest common factor of the polynomial. So that's what we factor it out. But then what is the other polynomial that we need to multiply? So that the product of the other polynomial and this 5x to the 4th power gives us 20x to the 8 plus 45x to the 6 minus 25x squared. Well, we can divide each of the terms here, 20x to the 8 by 5x to the 4th by the greatest common factor. So plus 45x to the 6th over 5x to the 4th minus 25x to the 4th over 5x to the 4th. So each, excuse me, will divide. So the first term, so we are going to put it inside the parentheses. 20 divided by 5 is 4. X to the 8 over x to the 4th is x to the 4th. Plus 9 x squared minus 5. So we factored out the greatest common factor and we wrote it as a product of its factors. Its greatest common factor in the polynomial. The second example, we have two terms here. This is the first term and this is the second term. Now, the greatest common factor for these terms is not a monomial, it's a binomial. Y squared minus 3, y squared minus 3, it occurs in each term. So that is the greatest common factor for this y squared minus 3. We pull it out. And what are we left with? We're left with, when we pull it out, we're left with 2xy minus 5. So we factored now this, okay?